Deep beneath the ground you are standing on, buried under thousands of miles of rock and pressure, something is hiding. For decades, we have looked up at the moon and told ourselves a comforting story. We say that 4.5 billion years ago, a protoplanet the size of Mars named Theia collided with the young Earth. We say that in this violent cataclysm, Theia was pulverized, vaporized instantly, and the debris formed our silver companion in the night sky. We tell ourselves that Theia is gone. But we were wrong. New evidence from deep Earth seismology suggests a terrifying alternative. Theia did not vanish. It did not simply turn into dust. Large fragments of this alien world survived the impact intact. And right now, as you watch this, two colossal continents of alien material are resting deep within the Earth's mantle. One lies beneath the Pacific Ocean. The other lies beneath Africa. They are denser than the rest of our planet. They are chemically distinct, and they are massive. We are not living on a single planet. We are living on a graveyard, standing on the skin of a world that swallowed another whole. The corpse of Theia is still here. To understand the magnitude of this discovery, we must first revisit the most violent day in the history of our solar system. Imagine the early Earth. It was a molten hellscape, barely cooling from its formation. Then came Theia. This was not an asteroid. This was a fully formed planetary embryo, careening through the darkness at thousands of miles per hour. When it struck, the energy released was enough to melt the surface of the entire globe. For generations, computer simulations suggested that this impact was a glancing blow, or a hit that completely mixed the two bodies together into a homogeneous soup. But there was always a problem with the math. If Theia mixed completely with Earth, the chemical signature of the moon should be exactly the same as Earth. But if Theia just glanced off, the moon should be made mostly of Theia. The reality is a strange mix that scientists struggled to explain. But what if the simulation was wrong because we assumed Theia was destroyed? What if the core of the alien planet punched through the Earth's crust like a bullet through an apple, plunging deep into the magma ocean before it could disintegrate? This is the giant impact hypothesis reimagined not as a merger, but as an invasion. The clues to this buried alien world were not found by telescopes, but by listening to the heartbeat of the Earth itself. In the 1980s, geophysicists began using a technique called seismic tomography. Think of it like a CT scan for the planet. When an earthquake strikes, it sends shock waves ringing through the globe. By measuring how fast these waves travel through the deep Earth, scientists can map the density of the material below. Sound waves travel at different speeds through different types of rock. Through cold, dense rock, they move fast. Through hot or less dense rock, they slow down. As researchers analyzed the data, they noticed something bizarre. There were vast regions near the core mantle boundary, nearly 1,800 miles down, where the seismic waves hit a wall of sludge and slowed down dramatically. They called these zones large low-shear-velocity provinces, or LLVPs. At first, they thought these were just plumes of hot magma. But as the resolution of our scans improved over the last 40 years, the picture became clearer and far more disturbing. These were not just hot spots. These were distinct, solid mountains of material with clear borders separating them from the rest of the mantle. Let us talk about the scale of these anomalies. The term large does not do them justice. These two blobs, often referred to as the Tuzo and Jason structures, are truly gargantuan. Together, they make up roughly 8% of the Earth's entire volume. If you were to bring them to the surface, they would cover the entire surface of the planet in a layer of lava 60 miles deep. The one beneath Africa stretches from the Atlantic Ocean all the way to the Indian Ocean. The one beneath the Pacific is equally massive. They are antipodal, meaning they sit on opposite sides of the Earth's core, like a pair of headphones clamping the center of our world. For years, the prevailing theory was that these were just piles of oceanic crust that had subducted, sunk down, and piled up over billions of years like a geological landfill. But recent studies published in the 2020s have shattered that idea. The density is wrong. These structures are between 2 and 3% denser than the surrounding mantle. Heavy material sinks, and these blobs are incredibly heavy, anchoring themselves to the bottom of the mantle like sunken ships. The breakthrough came when a team of researchers, led by Qian Yuan at Caltech, decided to simulate the Great Impact with a new variable. They asked, what if Theia's mantle was inherently denser than Earth's? They ran the numbers. The simulation showed that when Theia struck, its iron core would have quickly merged with Earth's core. But the rocky mantle of Theia, the shattered remains of its crust and insides, would not have mixed instantly. Because it was denser and richer in iron, huge chunks of Theia, some thousands of miles wide, would have sunk through the Earth's molten magma ocean. They would have fallen like stones through water, settling at the bottom, right on top of the Earth's core. Over 4.5 billion years, convection currents in the mantle would have swept these fragments together, piling them up into the two massive heaps we see today. This simulation perfectly matches the location and mass of the LLVPs. It is the most elegant and yet the most unsettling explanation. The blobs are not made of Earth. They are the actual physical remains of the planet that died to create our moon. This discovery fundamentally changes how we view the ground beneath our feet. We tend to think of the Earth as a series of neat layers: crust, mantle, outer core, inner core. We teach this in schools. We draw it in diagrams. But the reality is much more chaotic and terrifying. The interior of our planet is not uniform. It is a lumpy, heterogeneous mess. It is a crime scene that has never been cleaned up. If the LLVPs are indeed Theia, it means that Earth is a chimera. We are a genetic hybrid of two worlds fused together by violence. It implies that planetary formation is a brutal process of cannibalism. Planets grow by eating other planets, and sometimes the meal does not digest. These alien continents have sat there, dark and hot, for eons. They have remained separate from the natural convection of the Earth, stubborn remnants of a lost world refusing to be assimilated. It gives a whole new meaning to the concept of the underworld. There really is another world down there, buried in the dark. You might be wondering, if these things are 2,000 miles down, why should we care? How do they affect us up here on the surface? The answer lies in the plumes. The heat from the Earth's core has to escape, but these massive, dense slabs of Theia material act like thermal blankets, trapping heat at the core mantle boundary. This causes the surrounding rock to superheat and rise in thin vertical columns called mantle plumes. These plumes punch up through the mantle and burn through the crust, creating massive volcanic hotspots. And where do we find these hotspots? Directly above the edges of the LLVPs. The Hawaiian Islands, with their endless volcanic activity, sit right above the Pacific blob. Iceland and the supervolcanoes of East Africa sit above the African blob. The breakup of the supercontinent Pangaea happened directly above the African LLVP. These buried alien structures are literally driving the tectonic plates, ripping continents apart and birthing volcanoes. The ghost of Theia is still shaping the geography of the modern world. Scientists have even begun to look for chemical proof. If these blobs are truly alien, their chemical signature should be different from the rest of the Earth. And indeed, lava samples from hotspots like Hawaii and Samoa, places fed by deep mantle plumes, show mysterious ratios of noble gases like helium-3 and neon-22. These are primordial isotopes, older than the Moon itself. They match the predicted composition of a protoplanet like Theia. This is the smoking gun. Every time a volcano erupts in Hawaii, it is not just spewing Earth magma. It might be bleeding the ancient blood of Theia. We are literally breathing in the atmosphere of a dead planet every time one of these deep-source volcanoes erupts. The geochemical evidence is mounting, and it points to a singular conclusion. The deep Earth is not just rock. It is a reservoir of alien history, locked away in a high-pressure vault. There is also a fascinating connection to the Moon itself. If the LLVPs are the pieces of Theia that fell into Earth, then the Moon is the piece of Theia that escaped. This creates a poetic but haunting symmetry. The Moon and these deep Earth blobs are siblings, separated at birth by a cataclysm. One looks down from the sky, cold and cratered. The others look up from the depths, hot and compressed. They are made of the same star stuff, the same ancient planetary flesh. This theory also solves the lunar isotope mystery. If the Moon is mostly made of Theia, and the LLVPs are also made of Theia, and the rest of Earth is mixed, it explains why the isotopic compositions are so similar, yet slightly distinct. It unifies the history of the Earth and Moon into a single, violent narrative. It means that when you look at the Moon, you are seeing the reflection of what lies deep beneath Africa and the Pacific. So, what does this mean for the future of our planet? The LLVPs are stable, but they are not static. They shift, they pulse, and they dictate the thermal flow of our world. As our technology improves, we will be able to map these alien continents with higher precision. We might even be able to drill down and sample them one day, though that remains in the realm of science fiction for now. But the psychological impact is immediate. We are no longer just Earthlings. We are the inhabitants of a hybrid world, a planetary survivor. The realization that huge fragments of an alien planet are intact beneath us adds a layer of cosmic horror to geology. It reminds us that the universe is violent and that our existence is the result of a lucky survival in a game of cosmic billiards. Theia is not dead. It is part of us. It is holding up our oceans. It is pushing up our mountains, and it is waiting silently in the dark beneath our feet.